Hi guys, welcome to the next section, Day 7, Understanding Object-Oriented Programming with C#. In this section, we will see inheritance, member visibility in inheritance, implementing inheritance, abstraction, encapsulation, and polymorphism. Now, we move on to the first video of this section that deals with inheritance. In this video, we're going to take a look at Introduction to OOP. We'll then see object relations. Next, we will see inheritance and types of inheritance. OOP is one of the programming paradigms that is purely based on objects. These objects contain data. OOP has come into consideration to overcome the limitations of earlier programming approaches. Generally, I define OOP as a modern programming language in which we use objects as building blocks to develop applications. Let us go back to our programming world and think about a program that is defined. A program is a list of instructions that instructs the language compiler on what to do. To understand OOP more closely, we should know about earlier programming approaches, mainly procedural programming, structured programming, and so on. Structured programming is a programming paradigm that solves a problem to handle thousands of lines of code and divides these into small parts. These small parts are mostly called subroutine, block structures, for and while loops, and so on. Procedural programming, a paradigm derived from structured programming and simply based on how we make a call. Known languages that use procedural programming techniques are COBOL, Pascal, and C. The main problem with these two approaches is that programs are not well manageable once they grow. Programs with more complex and large code bases make these two approaches strained. In short, the maintainability of the code is tedious with the use of these two approaches. To overcome such problems now, we have OOP, which has the features like inheritance, encapsulation, polymorphism, and abstraction. Before we start our discussion on OOP, first we should understand relationships. In the real world, objects have relationships between them and hierarchies as well. The types of relationships in object-oriented programming are association, aggregation, and composition. Association represents a relationship between two objects in a manner that all objects have their own life cycle. In association, there is no owner of these objects. For example, a person in a meeting. Here, the person and the meeting are independent. There is no parent of them. A person can have multiple meetings, and a meeting can combine multiple persons. The meeting and persons are both independently initialized and destroyed. Aggregation and composition are both types of association. Aggregation is a specialized form of association. Similar to association, objects have their own life cycle in aggregations, but it involves ownership. That means a child object cannot belong to another parent object. Aggregation is a one-way relationship where the lives of objects are independent from each other. For example, the child and parent relationship is an aggregation because every child has parent, but it's not necessary that every parent has child. Composition is a relationship of depth that represents the relationship between two objects, and one object depends on another object. If the parent object is deleted, all its children automatically get deleted. For example, a house and a room. One house has multiple rooms, but a single room cannot belong to multiple houses. If we demolish the house, the room would automatically delete. Let's discuss all features of OOP in detail. First feature is inheritance. Inheritance is one of the most important features of OOP. It is self-explanatory. Inheritance inherits features from a class. In simple words, inheritance is an activity performed at compile time as instructed with the help of the syntax. The class that inherits another class is known as the child or derived class, and the class which is being inherited is known as the base or parent class. Here, derived classes inherit all the features of base classes, either to implement or to override. Inheritance as a feature of OOP helps you to define a child class. This child class inherits the behavior of the parent or base class. Inheriting a class means reusing the class. Let's see the representation of inheritance using a diagram. In this figure, the derived class, that is B, inherits all the features by ignoring modifiers. Features are inherited whether these are public or private. So here, public features, that is A, B, and C, will be implemented. Now, It's time to discuss inheritance types. The first, single inheritance. Single inheritance is when a class inherits another class. A class that inherits another class is called a child class, and the class which is being inherited is called a parent or base class. In the child class, the class inherits features from one parent class only. Here's the representation for single inheritance. The diagram shows Class B inheriting Class A. Class B can reuse all features, that is, A, B, and C, including its own feature, that is, D. Visibility or reusability of members in inheritance depends on the protection levels. The next type of inheritance is multiple inheritance. Multiple inheritance happens when a derived class inherits multiple base classes. C# does not support multiple inheritance, but we can achieve multiple inheritance with the help of interfaces. This diagram is a representation of multiple inheritance, which shows that Class C inherits from two base classes A and B. In multiple inheritance, the derived Class C will have all the features of both Class A and Class B. Another type of inheritance is hierarchical inheritance. Hierarchical inheritance happens when more than one class inherits from one class. In this diagram, Class B and Class C inherit from Class A. With the help of hierarchical inheritance, Class B can use all the features of Class A. Similarly, Class C can also use all the features of Class A. The next type of inheritance is multilevel inheritance. When a class is derived from a class that is already a derived class, it is called multilevel inheritance. In multilevel inheritance, the recently derived class owns the features of all the earlier derived classes. In this, a derived class can have its parent and a parent of the class. Here, the diagram represents multilevel inheritance and shows that Class C can reuse all the features of Class B and Class A. Further, we have the hybrid inheritance. Hybrid inheritance is a combination of more than one inheritance. C# does not support hybrid inheritance. Combination of multiple and multilevel inheritance is a hierarchical inheritance, where a parent class is a derived class, and a recently derived class inherits multiple parent classes. There can be more combinations. This diagram represents hybrid inheritance that shows the combination hierarchical and multiple inheritance. You can see that Class A is a parent class, and all the other classes are derived from Class A directly or indirectly. Our derived Class E can reuse all the features of Class A, B, C, and D. The last type of inheritance is implicit inheritance. All the types in .NET implicitly inherit from system.object or its derived classes. In this video, we saw the inheritance concept.